We'll start with this chapter, bacha, how forces affect motion. How forces affect motion. So we are going to study the introduction to force, balanced and unbalanced force, and obviously to friction. So we will understand all these aspects. So a force is basically what? A push or a pull. Okay. So when you're talking about contact forces, so actually forces can be of two types. One is wherein there is a contact between two bodies, and when there is no contact between the two bodies. So when there is a contact between two bodies, the force will be either of a push or a pull that acts upon an object. Okay. So what will be the effect of a push or a pull? It can move an object from rest. Let's say there is a football, you kick the ball and the ball moves. Okay. So it can move an object from rest. That is example, kicking a ball can change the speed or direction of a moving object. So let's say there's a bowler who is a spinner and the batsman hits him for a six. So what has happened? There's a change in the speed of the ball. Okay. Can change the speed, and there's a change in the direction of the ball. Example, striking a ball with a bat. Can change the shape of an object. Example, squeezing a lemon. So you have changed the shape of an object. So these are the primary things that the effect can, these are the effects of force. Object moves from rest, there is a change in the direction of the moving object, or there is a change in the direction, change in the speed of the object. It moves faster or maybe it moves slower. There is a change in the direction of the moving object, and there could be a change in the shape of the object as well. Okay. So all these are effects of forces. So what is an effect? A force is what? A push or a pull that acts upon an object. So effects of force can move an object from rest. So this was at rest and you have kicked it, so it moves. Can change the speed or direction of a moving object. So the ball was coming like this and you have changed the speed as well as direction. Can change the shape of an object. So let's say this is basically a lemon which you are squeezing. So the shape of the object is also changing. Magnitude and direction. Force is a physical quantity that requires both strength and a specific direction. ये एक physical quantity है और इसका this is basically a physical quantity that requires both strength and a specific direction. Vector nature, since it has both, any change in the magnitude or direction changes the effect on the force. Okay, so since it's a vector quantity, it has got both. Any change in the magnitude or direction. So vector quantity is what? A physical quantity is a vector quantity if it has got magnitude as well as direction. So force is basically a vector quantity. Force is a vector quantity and it will have magnitude as well as direction. So let's say I am saying that I'm applying a force of 5 Newton on the wall. So I'm applying a force of 5 Newton on the wall. Where is the direction? The direction is in this way. Okay. So let's say 5 Newton towards east or 10 Newton towards south. Aisa. Okay. So vector nature, since it has got both, vector nature means that force has got both. Any change in the magnitude or direction changes the effect of the force. Okay. The magnitude of the force expresses how strong the force is. So if I, let's say a force of 10 Newton, let's say I say a force of 7 Newton, which one of them is more stronger? This force is more stronger. Okay. So magnitude will tell you which force is more stronger, and direction will actually tell you the direction in which the force is applied. Okay. Force is a vector quantity. So force basically is what? A vector quantity. Force requires both strength and direction. So strength is basically magnitude. Let's say I am applying a force of 50 Newton on this box. Okay. So the direction is in this way. Okay. Again, I am applying a force of 20 Newton on this box. So the direction is this way. So change any component, you will change the impact. किसी भी component को अगर आप change करेंगे, direction को या magnitude को, तो उसका impact change हो जाएगा. If you change either the direction or, so let's say अगर समझ लो कोई बैट्समैन है, वो सेम फोर्स से 6 मार रहा है, तो एक 6 मारा उसने इस तरफ गया और एक 6 मारा उसने ऑफ साइड में गया. दोनों भी सेम फोर्स उसने अप्लाई किया, लेकिन इंपैक्ट अलग अलग हो गया. In one, the ball has reached there, and the other, the ball has reached there. So the impact or the effect has become different. If you, so vector nature means that it has got both magnitude as well as direction. You change any one component, the force itself will change. Okay, change any component, you will change the effect. So let's say the initial force was 100 Newton towards the east. The cart was moving towards the east. You change the magnitude. Let's say you change it to 150. You are not changing the direction. You are changing it from 100 Newton to 150. Will the cart move faster? Will the cart move faster? Obviously, we will increase the speed, so the increase the force, so the cart will move faster towards east. Now, what you do is you change the direction. You don't change this, but you change the direction. Force is the same, but you have changed the direction to northeast. So the cart moves in a different path. Okay. So force is a vector quantity. It will have both magnitude and direction. If you happen to change either the magnitude or the direction, the impact will become different. Are we clear on this? Okay. Magnitude is strength. So light, so let's say light, this is basically 10 Newton ka force, this is 50 Newton ka force, this is 200 Newton ka force. All these are different in magnitude. They might have the same direction, but they have different magnitudes. Okay, if I happen to push this, I need a force, but this will be hardly any force. But if I need to push a vehicle which is outside, I would need a very greater amount of force. So all these are different magnitudes. Okay, are we understanding the difference between magnitude and direction? Both are the components of a force. So a force will be made up of both magnitude as well as direction. If you happen to change any one of them, the force itself will change. And if you happen to change both, obviously the force will change. Okay. A single entity with both size magnitudes. So what is a vector quantity? A vector quantity is a quantity which will have both magnitude as well as direction. Both magnitude as well as direction. So SI unit means standard international unit. Standard international units. Any physical quantity will always have a standard international unit because we need a uniformity about all units. So there was a conference that was held in Geneva, and there it was decided that all physical quantities will have a unit. So force is having a unit of 1 Newton. Now understand, when we will study in deep, force is mass into acceleration. Mass is measured in kg. Acceleration is measured in meter per second square. And the unit of force is 1 Newton. So 1 Newton is equal to 1 kg meter per second square. 1 kg meter per second square. So 1 Newton is 1 kg meter per second square. Are we clear on this? Okay. Measuring tool. A spring balance is used to measure the magnitude of a force. So basically, a spring balance is used to measure the magnitude of a force. Weight. It is actually the gravitational force with which the earth pulls an object. So weight is the gravitational force with which the earth pulls an object. Are we clear on this? Okay. Definition. When two forces of equal magnitude act in opposite directions on an object, they are called balance forces. When two forces of equal magnitude, so let's say there is a force which is acting here of 20 Newton. There is a force which is acting here of 20 Newton. When two forces of equal magnitude are acting, these are called balance forces. This force will balance this force. The object is not going to move. Or let's say we have an object here and you are pulling it with a force of 20 Newton this side. You are pulling it with a force of 20 Newton this side. Is the object going to move? No. Okay. So if you have a tug of war, so when you are having two teams which are pulling it with equal strength, the rope is not going to move because the rope is now balanced by the two forces which are acting in balanced direction. So whenever an object, so see, it's not necessary that an object is at rest, because see, okay, let's say there's a tool here and let's say we have an object which is kept here. Is any force acting on this object? Is there any force acting on this object? So let's say now there's a force that is acting, right? So right now, is there any force acting on this object? Yes, there is a gravitational force. So there is a gravitational force which is acting on the object, although it is at rest. So why is it balanced then? So there is a normal reaction acting on it. There is a normal reaction by the surface exerted on it. So this normal reaction and the gravitational forces are balancing each other, and hence we call it as a balanced force. Under the influence of a balanced force, the object is not going to move. If an object is being acted upon by balanced forces, the object is not going to move. Now let's say मैंने यहाँ पे दो ऐसे ईंटें रख दिए और उसके ऊपर हमने यहाँ पे एक पेपर रख दिया और इस पेपर के ऊपर इस रिमोट को रखा, तो क्या होगा? नीचे चला जाएगा. What happened now? So see, I have kept two things like this and I've kept a paper over this. Now I'm trying to keep the remote over this. First of all, this was a table surface and I kept the remote, it is balanced. So what is happening? The gravitational force acting downwards and the reactionary force acting upwards, they are balancing each other, and hence we don't see any impact. Okay. Here what is happening? The paper is generating a reactionary force and there is a balance, there is a weight which is acting downwards. But this time the reactionary force is lesser than mg and hence it goes down. The balance is getting disturbed. So till the time an object is at rest, it doesn't mean that there are no forces acting on it. If an object is at rest, it doesn't mean that there are no forces acting on it. What it means here is the actioner and the reaction forces are balancing each other. Okay. So the net force is zero. The net force is zero. The object does not change its state of rest or motion. Tug of war, where both teams pull with equal strength, and rope, it stays still. So that is an example wherein it is balanced force. Okay, balanced force का मतलब समझ में आ रहा है. So an object which is at rest might be being acted upon balanced forces. Okay. So definition: when two forces of equal magnitude act in opposite directions on the object, they are known as balanced forces. So let's say this is a box, a 10 Newton force is acting on this side and a 10 Newton force is acting on this side. These two forces are going to balance each other. Okay. Result: the net force acting on the body is zero. The net force acting on the body is zero. Okay. The object does not change its state of rest or of motion. So the object is not going to change its state of rest or of motion. If the object is being acted upon by balanced forces, the state of rest or of motion of the object is not going to change. So tug of war is an example where both teams pull with equal strength. So this is an example where both the teams are pulling with equal strength. The rope stays still. The rope is neither moving towards this team, neither the rope is moving towards that team. Okay, this is a classic example of balanced forces. So even if the rope is being acted upon by two huge forces, there is no movement. पढ़ा रहा हूं गधे की तरह, ऐसे सर नहीं बोलते बीच में. So when we are pulling this, so this will not move because it is balanced forces. क्या चाहिए? Okay, are we clear on this?